saying they only change electron density for oxygen.
Yeah, or even for these, only change in electron density for any kind of electrons that are pi. But the sigma bonds stay intact, they don't move. Sigma bonds are intact, carbons are what they are, connectivity is always the same, 6-membered ring. I do not make anything weird. Right?
It's the same thing.
Yes, so even if it's a benzene case where you just move pi electrons, sigma bonds stay. Same thing here. Sigma bond from oxygen to carbon stays. Sigma bond from carbon to oxygen stays. Sigma bond from carbon to this carbon stays. You don't make any new sigma bonds because that's not allowed when you do resonance. I mean, you make new sigma bonds when you have to do reactions between A and B, like electrophilic addition, a double bond. You actually made new sigma bonds. That's because that's a reaction. Okay. This is not a reaction rate. This is just moving of electrons, and you still have the same structure. Right? It's a big one, because I'm sure I'm going to see something like this, some weird stuff. I'm sure I'm going to see this on exam 3. Rule 2. Okay, which example do I have? Okay, I don't like this one. Okay, what about this rule 2? CH3, same old, carboxylate here. For example, this is what I did. What can I put here? Let's say I take this and move it to this carbon. And now I have generated CH3 plus, right? Minus, O minus. What I'm saying, I generate a negative charge on a carbon, which is bad. So electronegative atoms should host a negative charge. By rule, the rule is, though there's some, you'll see variations as well. But the major rule is the electronegative atom should host a negative charge. So keep in mind. For example, this right here, CH2, CH2, right? Oh, here's the pi electrons. Oh, I can do resonance. Oh, look at me go. Okay. Then what do? This is what I form. Is this okay? I took the pi bond. I didn't break a sigma bond. And did I break any octet rules? No. Right? Here's one example where this thing has 8 electrons. This thing has 6 electrons. That's still below 8 or at 8. That's acceptable. I took a pi bond, I did a sigma bond, that's still acceptable. But what is wrong here? That's another rule.
The electrophile.
The problem here is I'm slicing this pi bond and creating plus and minus on the carbons that are of the same electronegativity. There's no reason to do this. This is not stabilizing anything. You are creating, because carbons have same, 2 carbons have same electronegativity. There's no reason for us to create partial charge separation. There's just no reason to do this. This is not acceptable. So the other rule is then, what did I call it? I had a special name for this. And this is that rule. Okay, the rule was that the most stable between the two, for example, resonance contributor is the one with less charge. So, less charge separation. So, if you create multiple charges, that's one hybrid resonance contributor. Then you have another resonance contributor. We only have minus something. Then that minus single charge is better than having plus minus all over the place. Creating charges, multiple charges, is not preferred. Yes?
What's the second word for blank resonance contributor?
This?
Yes.
Most. Oh, that's pretty readable. Yeah, I can read that when I go back. Sometimes I can't even read my own writing. The most resonance. The most
Stable.
Thank you. The most stable resonance contributor is the one with less charge or less charge separation. So if you have a resonance contributor that's neutral, meaning no formal charge overall, and no formal charge on carbon, and then you have resonance contributor, you think, and now you create a charge separation. This resonance contributor, for many reasons, in addition to this one, is not a stable resonance contributor. You don't draw this. It's not right. You don't draw that. So you do not want to create more negative charge or more positive charge. You want to maintain as minimum as possible charge on things. Okay, is the one with less charge, i.e. less charge separation. Okay, so I'll move on to, oh, the octet rule we already covered, right? You should follow the octet rule. You can move the electrons about if everything has 8 electrons. Yes. You move the electrons about if everything has less than 8 electrons. Yes. But you cannot move the electrons about to create something that has more than 8 electrons. That is not allowed.